Hey folks, sorry about the delay. Um, there was a rendering error on uh, in my browser on YouTube. I don't know why, but it was showing me that the stream was not rendering correctly, and it was rendering correctly. So I just confirmed that through another method. So apologies for that. I don't know what's going on with that, but we're good to go. We can get started. All right, so I do see some activity here. We have a few people asking some questions. Somebody's asking about optimizing some code. Let's see here. All right, so I'm trying to optimize this code. It works. It just takes too long for incredibly long arrays. Okay. Um, Send me a link to where you found this problem, and I'll go from there. We got another question. Can I walk through this function step by step? The correct answer is 50, but I'm having a hard time following it. What would the following code print? Also, can you give me a link for that? How much longer till my new machine arrives? That's fair. I cannot wait to end this nightmare of this limited machine, streaming on this limited machine. I placed my order for the machine, was it yesterday? Yeah, yesterday, and no, 2 days ago, and my order was confirmed today, so I think it'll be here within a week, 5 to 7 business days, so I'm very excited for it. I mean, like, I know, right? Sheesh. Okay, never should be this complicated. All right, so we got a link to the one question here. Thank you for that. This is in Learn. And to the person asking the question regarding wanting help optimizing that code, I mean, if it's working, then, and if it's like not passing a test or something, I can't really give you helpful advice unless I have access to that test. So do give me a link when you get a chance, and I'll be happy to go through that. Oh, cool. You've DM'd it to me. Lovely. All right. So I'll take that one next. Question 3. All right. Oh, is this question 3? So the question is, oh, let me look at this. What will the following code print? Okay, so we just want an explanation of this. Okay, yeah, I remember this question. So, I laugh because this code makes me laugh. Not at your question. I mean, this code is obscene. In reality, somebody may have a different opinion about this, but I've never needed to define a function inside another function. There may be a case to do this. It's valid Python, but I mean, just look at that. It's not even that much code, and it's just a mess. So yeah, I don't blame you. This is pretty wacky code. Okay, so supposedly the correct answer here is 50, and we just want to like look at this and have an explanation. So I like to kind of work backwards. I mean, this is sort of a theme that I'm sure if you've seen me stream or watched my classes or we've worked together before, you've kind of heard me say this, kind of working from our expectation backwards. In this case, we know the expectation because it was supplied to me by the person who asked the question, but really we're supposed to figure out what this code does. So we'll work backwards in terms of we'll look at the call, and we'll look at then we'll look at the definition, and we can follow that pattern from call to definition to find out what's going to happen, kind of, right? And I'll show you. So I see here on line 14 we're invoking this obfuscation station, which, yeah, that's what that is. Unnecessarily obfuscated code. Hilariously obfuscated, if you will. So the question is, what does this function return? Well, its return is here, and that's because this return is the first thing. It's in the lowest tab level while still being in the function, right? So this function's return is on line 11 here, and it's going to return 10 times whatever mysterious inner function returns. So let's go look up for that. So we have doubly mysterious, and then we have mysterious inner function. So, okay, so whatever this returns times 10. Oops. Let's see. Can I? All right. And then mysterious inner function, we have x equals 5, and then it returns mysterious, or excuse me, it returns doubly mysterious, and it passes 2. Doubly mysterious takes in x and returns 10 over x. So 2 gets passed, and x retains the value 2. So this will be, oops, return 10 over 2, which is 5. So doubly mysterious will return 5. Mysterious inner function will return whatever doubly mysterious returns, which is 5. And then, let's see, obfuscation station will return 10 times whatever mysterious inner function returned, which is 5 times 10, which is 50. So that's how I would reason through this code. So you can do this yourself by looking. I think it's easy to, so it's easy to look at this code and to start from the top and say, okay, well, we have this definition, and kind of read down line 3, line 4, line 5, line 6. But it's important to remember that, the Python will parse the document in that order, but it doesn't execute it in that order. So you want to follow the path that it executes on, right? So the first place to look is at the invocations, right? Even though they're below the definitions, it's a little inverted, but this is the first place to look. We have the invocation here, and then what's that invoking? So this is the second place to look, because that's what it's invoking. So now the question is, what's it returning? And we're going to keep asking this question, what's it returning? Right, so it's returning this. So this is the third place that I look, because that's what it's returning. So it's returning a call to another function, which is up here. You see the pattern? So this pattern is not accidental. This is a pattern that I know because I've gone through it, not just with this question, but with various other functions. Like I said, I've never in like real coding actually defined a function within a function. I think there are workflows where this is done. To me, it just seems, I don't know, pick a strong word that is a synonym of disgusting or something. It's hilarious to me, this sort of function within a function within a function. You know, maybe there's a case for this in reality, but it's more like you have these unnested, right? So we could write similar code while just unnesting these, right? And we would have essentially the same thing. I think this will even work exactly the same in this particular case. Perhaps in all cases, but let's see what this does. It's going to run? Okay. Yeah, so this is also going to give us 50 back, right? So whether they're nested or whether they're unrolled like this, which seems like the sane way to do things, it's going to work the same, and we're still going to go for, you know, we're still going to look at the invocation and then the definition and ask, when we look at the definition, what is this returning? And we're going to look at the return and sort of justify that return against whatever, you know, internal process that this code has, that this function has. In this case, there really isn't any internal process, that they all just have a return line kind of immediately. So yeah, so this is the third place that I'll look, which is itself an invocation. So I'll look at the definition for that invocation, which is here. And again, I'll ask the question, what's this returning, right? And I'll look here. This is 5.5, and then we'll come up here and we'll say, what's this returning? Okay, what's this returning? And it's returning this, right? So I think one of the an additionally confusing thing, a curveball that they throw you, is this right here. And well, notice, I think it makes more sense when these are unrolled for a number of reasons. When these unrolled, meaning unnested and, you know, out here sort of where they belong. This is just a false lead, right? So it's meant to confuse you as to whether, you know, this X is being used here or if it's this X, right? And in any case, if there's some parameter that has the same name as some variable in some containing scope where that function is, the parameter will override the variable unless the variable is local to the function, right? So this X is not local to this function, which takes in a parameter by the same name. Therefore, the parameter will override it every time, right? So if I say X equals panda bears, pandas are not bears. Pandas are not bears. Okay, then if I print X, you know, this local X is going to override this weird string of X. So that's an additional gotcha that this question has. So hopefully that's clear. I wanted to make that process sort of clear and how I would go about tracing code, right? Start with the invocation, go to the definition, ask what it's returning, and then sort of justify that return. I mean, by which I mean look at that return and then make it make sense by reading through the internal process, which that step really isn't represented in this process, but that's what you'd do. So look at the return, look at the process, kind of make that return make sense. Any invocations of functions that you're not familiar with, if those functions are available in the code base that you're looking through, then go look those up and do the same thing, right? Rinse, wash, repeat. Cool. Therefore, the answer is 50. All right, we can move on. Oops, and somebody DM'd me. Oh, defining functions inside of other functions is a part of functional programming. Yeah, I guess it is. I guess that's true. It is. I like functional programming. Well, yeah, I like functional programming. It's rather cool at times. Okay, so we've got a link to a problem here, and I'm just going to look this up really quick. The request is particularly to optimize some code. And I'm going to just give this a quick go, see if I can make this work like right off the bat. And if not, then I'll need to follow up about this code after. Okay. Execution timeout. Okay. Okay. I think I might have a solution for this. So the question here, let's see. Not sure if this is going to get it to pass the tests, but we'll go over this because this is kind of interesting code. So I'm going to give you my thoughts, and you can just let me know in a DM if this is actually going to help you. So this question is from a code practice site that I won't mention at the moment, but perhaps you could DM the original asker of the question, and they may be willing to share. So from these tests, we can kind of look at what this is supposed to do. So find unique is supposed to return the unique value, right? So the value that only has one occurrence. So we have a list of ones, and we want to get only the 2 out of it, right? So the 2 is gonna is the unique value. This 0.55 is the unique value, and then this 10 is the unique value. So I think what's happening here is, since we have a for loop, we're checking everything. I think we can optimize this by saying return. I'm going to do a comprehension here, and we're really only going to have a comprehension that has only one element in it. So a list comprehension gives you a list back, and I actually want to just return the one element that's going to be in the list. So I'm going to say in for in for in, I for I n. That's better. I for I in arr, which is short for array. for those of you not familiar, an array in Python is synonymous with a list, or most languages will call. So Python has lists. Most of other languages have a type that's very similar, usually called an array instead of a list. So an array is a term that you'll hear in Python that just, or in programming in general, that the Pythonic analogy is just a list. Okay, so we'll do I for I in array. If array dot count I equals 1. So let's just try this. Okay. So this would be a comprehension solution. Comprehensions do stand the chance of potentially being more highly optimized and having a better runtime story. I'm going to submit this to the link that the person DM'd me, and we'll see. I'm not entirely hopeful that it's going to accept this, but whatever. Perhaps there's some other sneaky way that it wants us to do this. Yeah, I feel like it's not going to work. Yeah, this times out as well. Sync up with me about this later or after study hall, and we'll go over this further. So this is I think we could do this, but it's gonna take a little longer than I have for I don't want to take up all of study hall with this, but we could probably look up some additional methods that might optimize this further. And there's probably something really obvious that I'm just missing, but that's okay. So sub-0 at the end is, take a look at this output. This is what I want. I want the numbers themselves. Yeah. So if I don't include this, I'm going to get a list with those numbers. A list with a single element, which is the element will be the number. I wonder, you know what? I'm gonna try this out real quick. I wonder if there's a string method. I have this hunch that there's a string method. I have a suggestion for a set. Oh. Oh, that's interesting. Yeah, we could compare it to a set. So we could say, yeah, it is a good idea. So if we cast this to a set, we could say for L in set array, and I know there's been some changes to sets lately. Ten and 3. Okay, cool. So this way we're only iterating through a couple elements, and then we can do if array.count L equals 1, return L. Is that going to do it? I think that'll do it. Cool, and we can further optimize by doing return, I'll just make this a comprehension, return L for L in set array if array count L equals 1. Oops, just that. Okay, yeah, that should be quite a bit more optimized. Good thought there. It's one of those things where it's like, oh yeah, it's obvious once you think about it. Okay, so again, same sort of deal, right? I don't have sub-zero at the end of this, so I'm returning a list with a single element, and I actually just want to be returning the element, not the list with the element in it. So we'll do sub-zero to just pop that element out of there. Cool. Well, let's try that in the solution. Cool, looks like it worked. Cool. All right, I'm not seeing any other questions. I'll just scan through here real quick. Yep, I'm not seeing any other questions. So let's move on. All right. Cool, so we're going through this manipulating lists overview. Okay, we'll just skip this. This is the overview. We'll talk about copying. So copying, the next section is on mutability and modifying lists. Copying, really understanding why we should copy something sort of comes with the understanding of what mutability is. Oh, we have a question. I'll get to that after I go through this section on copying here. So the reason that copying is useful is because lists are mutable. If lists were not mutable, we wouldn't need to copy them. So let's look at a string versus a list and talk about modifying those and what it means for something to be mutable. So if I have my string equals, and I pass this to my function, we'll do that. There's nothing that I can do to the string here that will alter this global copy. So let's say I'll do this. I'll call it my global string. So I pass in my global string into here. It gets represented as string. If I print string, here. Right? There's nothing that I can do to this string that will change this global copy. So let's just print out the global copy. Well, I'm calling it a copy. That's kind of confusing. Global, we'll just say global is global variable. Okay, so here's the global, right? So if I say string equals empty string, well, that's going to override the value of the local parameter called string, but it doesn't override this global string here, right? Let's say I have a list. Here's my list. Okay, so let's say that this, I also take in a list into my function, and we'll pass my global list. And we'll print out the list as well. Okay, I know I've got a bit going on here, but I'm going to go over all of these points and kind of try to make sense of this soup. So the list, let's just look at this path of this list. What's happening with the list? I'll just comment out the string bits for now. So here I create my global list. I pass it to the function. I'm going to print out the value of the list. So take note of where it starts and what I'm going to do to it in a second here. So I'm going to say list dot clear, and clear clears a list, right? So if we notice, I'm saying, now obviously I'm doing this in a different way because strings don't have a clear method because they're immutable. So I can't do string.clear, but I can do list.clear. So if I override string, the parameter is called string, I'm just changing the value of the parameter. I'm not changing the value of the global variable. If I clear the list, I'm not just clearing the parameter, I am clearing the global variable list, my global list right here. So let's look at that. So if I print out, so the global list is initialized here. We pass it to the function. We clear it internally. Oops. Oh, right. I misspelled that. Okay. So we declare it here. We pass it to the function. It gets represented as LST here. We call list.clear. And then let's look at the global value now, right? So the global value is an empty list because I cleared it. So this literally operates on the global value. So hopefully it's obvious why you don't want to do this. In general, I think it's safe to say you never want to do this. You never want to write a function that takes in an argument that you alter the value of, where that alteration affects the global copy, right? So with lists and other mutable types, right, this is a demonstration of what it means for a list to be mutable versus a string which is immutable. So if I want to, let's say I need to clear this or alter this, right? Another example of altering the list would be dot append. modified. I think, I don't know how do you spell it. Okay. So if I want to do this, if I want to modify this list for whatever reason, if I want to take it in as a parameter or as an argument and then modify it, I probably don't want to, I mean, I'm going to say you always want to avoid modifying it in such a way that it'll alter the global copy. In that case, we can list equals list dot copy. So here's the original list. Notice I called list.append modified here. Let's print out the copy of that list. Cool. So here's my list modified, and here's my list. So this allows us to make a copy, and then if we need to do any alterations to that parameter, we still have the same data, but we're altering a copy of it rather than the original. So this is much better, much more desirable, right? So let's look at this in a different way as well. Oops, I'll just do this. So let's say my list equals, I'll just do the same thing. Here's my list, and I'll say this is list 1, list 2 equals list 1. You might think, oh, well, okay, so this would be a way to copy. It's just to be clear, this is not a valid way to copy a list. And let's look at that. If I alter list 2, and I print list 1, even though I altered list 2, it changed the value for list 1 because these two identifiers, these two variable names, both point at exactly the same list. They're both pointing at the same location in memory, which is this particular list. So if I modify one and access the value of the other, that's what's going to happen. So if I actually, so this is sometimes called a shallow copy because it's a copy of sorts. I don't know. I mean, it's like you're adding another name tag to it. Really, it's not really a copy at all. But it's sometimes called a shallow copy. So we want to do a deep copy, which is copy.copy. And this same method exists for sets and dictionaries as well. So notice, if I do a deep copy, we have list 1, here's my list, list 2 equals list 1.copy, then we append to list 2, we print list 1, and it stayed the same, so we did not modify list 1 in this case. We'll print list 2, and here's my list modified. So list 2 has been modified, whereas list 1 has been left alone. So another way we can demonstrate this, if let's say I don't even modify it at all. If we want to know if two lists are the same, literally the same list, we can ask for the ID, right? And if the ID matches, the ID is going to be a sort of arbitrarily generated number. Well, that's a long string of zeros. It's kind of neat. It'll be this number. These are the IDs, and if they're the same, then it's obviously it's the same ID. It's the same list. Obviously, we can see that these numbers are different. You can just look at the right-hand side of the numbers to tell quickly whether they're the same or not. And usually, the last, in the last 3 or 4 numbers, it'll tell you. So these have different IDs, which means they are literally different lists. If I comment out this copy, so we're doing a shallow copy again, list2 equals list1 with no dot copy after it, and I just did that to comment it out. Then we'll see that these lists are going to be the same, and same sort of deal. Since I'm modifying a list that has the same ID, you know, it's not a list that has the same ID, it's just the same list. Therefore, it has the same ID. Right? So if I ran this line, it would modify both, whereas if I ran it now, it would only modify one because they'd have different IDs. So ID can be useful if you're, you know, if you have a list or another mutable type that's changing in a way that you don't expect, you can kind of start throwing around printing IDs of things and seeing when or if things are different. And if you want to distinguish one object from another, provided it's a mutable object, only mutable objects are really prone to this problem, in this way at least, then you can use .copy to distinguish one object from the other. That gives you the same data, although in a different object, so you don't alter your original or whatever. All right, cool. So let's go through copy. I'll just do, is there just one? There's just one. Okay. Sorry about that. Write a function called return a list copy that takes in a list. Def takes in a list. As an argument, the function should simply return the copied list. Okay, so return list.copy. That takes in a list as an argument. The function should simply return the copied list. What did I do? Am I crazy? Oh, I gave it the wrong name. Weird. Okay. I must have not copied that when I thought I did. Okay, I just named the function the wrong thing. Yeah, so here's a couple variations on that. Suppose I should mention there are other ways, there are other things that you can do that will implicitly copy a list, right? So let's see. Another way to copy is by slicing. So you can do what's called a full slice, which is all the elements in the list. So list subcolon or list subcolon colon. I always use the double colons in my slices, even if it's an empty slice like this. So this is every bit as much a copy as .copy. But it's not that because they thought, hey, it'd be nice to copy lists by saying square brackets colon colon. It's a copy because it's a slice. Anytime you make a slice of the list, you have to get a different copy out. It evaluates as a different copy of the list. So that's also a de facto copy. And then there was another way. I'm blocking on it for some reason. I'm going to kick myself when I remember it. Okay, never mind. So yeah, these are the two ways. So we can either use the .copy method, which is what I recommend that you do, or the subcolon colon, which will also give you a copy. Sometimes you'll see the slice way out in the wild, so it's good to just know what that is. Cool. Forgot we have a question here. Let me take the question. Sorry to keep you waiting. Okay, we don't have any code provided for this, but it's just a request to go through question 3, which it looks like this is. All right. Oops. So I'll just work through this in my editor where I'm happy, in my happy place, which is Atom here. Okay, cool. Write a function called isNumber. All right. Looks like we've got some tests here, or almost tests. Ah, okay, cool. So those I'll just use those as tests, and we'll def not a number takes in a, looks like it takes in a string. I'm gonna call it text, and returns one of these 3 things. It looks like. Okay, so let me actually read through this, make sure there's nothing I missed. So notice I'm just trying to get an idea of what this does just by reading the tests. A lot of times that'll just tell you. Okay, cool. Write a function called isNumber, which takes a string as an argument and returns the type as a string. If the string is indeed a number, then return not a number. If the string, oh, and I would say and return this, return the string, not a number otherwise. Okay, if it's not a number. Okay, so I guess you just go through and check and make sure every digit, yeah, okay. So we'll say for character in text, if character not in, I guess I could do, yeah, so if it's not in period 0, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are valid characters for numbers. I'm adding period in there because floats contains periods. So if at any point the character is not a member of one of these, then we'll just return not a number. Then we'll say if, I'm going to handle an edge case here. So if there's more than 2 periods, so we'll say if text dot count period is greater than or equal to 2. So if it's equal to 2 or more, then we'll also return not a number. Okay, cool. So this handles strings with multiple periods. This handles characters that aren't digits. And then we'll say if dot in text return float, else return. What does it need to return if it's a number? If the string is not a number, return its. If the string is a number, return its type as either int or float. So just int. Okay, good. Oh, forgot a colon. Parent, which is like print. There you go. Float, float, not a number, not a number, not a number, not a number. Okay. Let's do a an int as well, and this should be int actually. Okay, cool. That looks like it works. Let's test it. Looks like I have some other solutions from other times that I solved this problem. I'm just gonna do, oops. There we go. Okay, so let's run it and check it out. All right, so it looks like, assertion error, int, not equal to not a number. Ah, yeah, so this case we're checking empty string and we're expecting not a number. So I have to just make sure, so if text equals empty string, you know what, I can just do this here. Since it's the same, I can say if text.count dot is greater than 2, greater than or equal to 2, or this. Either one of these, I'll return not a number. Cool, so that'll work. Awesome, hopefully that helps. Okay, it looks like we've got another one here. So we're talking about negative slicing or negative ranging. Let's talk about negative slicing. Okay, yeah, let's just, I think we can just kind of cover positive, negative numbers in slicing. So, I'll just do this. So let's start with a list, so we have something to slice. And let's do list equals, we'll say okay. It's a little bit silly here, but that's okay. Okay, so I'll just print it out. That seems like the easiest thing. List sub colon colon. Okay, so let's talk about a few things. So when we're slicing, and this is why I'm just in the habit at this point of always putting in both colons. And if you're just learning slicing, I suggest that you do this. You don't have to, and you will see slices with only one colon. If there's only one colon, this sort of creates two sections in the list. That'll be start and stop. If there's two colons, it creates a third section, which is step. So I always do both colons because it sort of reminds you there's a start, a stop, and a step, and it's just consistent that way. So I think it's easier to learn if you're new to it that way. That way you always have those three sections represented. Okay, so if I leave the start empty, it's going to assume that I wanted to start at the beginning and yeah, go to wherever it stops. If I leave the stop empty, it's going to assume that I wanted to go from wherever I said to start all the way to the end. If I leave the step empty, it's going to assume that I want steps of +1, meaning that we start here or wherever, and then we go in step of 1, which is just the next number, 1 is just the next number, 1 is just the next number, right? So if I wanted every other number, like 55, 77, 99, 222, I could do steps of 2, right? And hopefully this is clear why, talking about it this way, why this is a full slice, why I call this a full slice, and why this copies the list, right? Since a slice gives back a subsection of the list, it has to give back a list of a different ID. If it gave back a list of the same ID, it would be modifying that list, which you kind of don't want to do for obvious reasons. It kind of defeats the purpose a little bit of what a slice is, which is to give you some section of that list without modifying it. So hopefully it's obvious. If I leave all these blank, I'm saying start at the beginning, go to the end, and take steps of -1. Give me all the numbers in steps of steps of +1, right? So that positive meaning it's going to start at index 0 and then add +1, so it's going to go to index 1 and then add 1, index 2, etc., right? So it's just counting up the indices of this list. So if I tell it to subtract indices instead, if I tell it go in steps of -1, well, in this case, I'm not telling it where to start, so it'll start at 0. I'm not telling it where to stop, so it'll stop whenever it reaches the end. And I'm telling it steps of -1, so what it's going to do is start at 0 and then go, oh, but I should do steps of -1. So the first thing it's going to do is give me this 3, 3, 3. And then it's going to take another step of -1, -1, -1, etc., till it gets to the the end, which is the beginning in this case. So this will reverse the list. So list sub : -1, start at the beginning, go to the end, take negative steps, so go backwards. So if I print this out, I'll get 3, 3, 3, 2, 2, 2, 1, 1, 1, etc. So that gives me a reverse. Okay. So if I want to do some negative slice here, I can tell it, let's say, I want to do 77 through 111 here. So I want to tell it to start at 77 and go up to 111. So we'll say the index of 77 here is 0, 1, 2. Tell it to start as 2. And the stop is excluded, so 3, 4, 5. 5, I have to include it, so I have to add one more. It's 6. Right, so notice, oh, and I meant to say I wanted 111 through 77 here. So notice, if I were doing steps of +1, this would work, but it doesn't really know what to do when I tell it to start here and go up to here, but take steps of -1, so I end up just with a sort of an inverted range, and it doesn't know what to do. So Yeah, so I have to make this positive 1 in order for that to work. But what I could do, I'd have to play around with this a little bit. Let's see, what would I, maybe 1 and then 5, I think. I think that's it. Yeah. Yep, okay, cool. So I'd have to think about that every time. So I'll tell it to start at 5, take steps of -1 and go, which means go to the left, and then stop at index 1, stop short of index 1. So this is index 1, and it's going to go 5, 4, 3, 2, stopping short of index 1. Cool. All right. So we have a follow-up, it looks like, to this. I'm trying to understand negatives and how they work in slicing. I would think it would return 19, 18, 17, but an empty list comes back. Ah, okay. Oh, in this particular example. Cool. Looks like you're saying that that's making sense. Hopefully that's good. I think this is kind of a similar question. Yeah. Cool. Sounds like we're good on this one. Yeah, I would say with this, just remember start, stop, step. You can also, yeah, hopefully it's clear. Well, I guess I feel like I should mention this as well while we're talking about negative numbers with slicing. There are times when you want to stop. Let's say you want to include everything except the last 3 elements of the list. Well, how do you count from the left and stop at the last, stop short of the last 3, unless you know the size of the list? Well, you could get the length of the list, and you could tell it to index up to the length of the list minus 3 or 4 because it's exclusive. I don't know. It'd be one of those or the other. I'd actually have to do it. I don't want to brain that out at the moment. That's where my dyslexia is in full overdrive. However, you can also count from the right. You can say, if I wanted to include everything except these last 3, I could count from the right and say -1, -2, -3. So it's going to go up to and not include -3, so I can just say -3 here. And it'll exclude that, right? Oh, excuse me, that's steps of -3. I meant to do this and stop. I want it to stop at -3. So we'll start at the beginning and we'll go to the end, yeah. So if you're ever thinking, oh, well, I want to stop, but the place where I want to stop, it needs to be relative to the end or the right-hand side of the list. You can use negative indices for that. So this will get us up from 55 through 99 and doesn't include those last 3. So there are times when you'll want to do that, when you'll want to measure your starting or stopping point based on the right-hand side or based on the end of the list, right? Since lists don't have you can't guarantee the size, right? Maybe you're slicing, at one point you're slicing a list that has 3 elements, at another point you're slicing a list that has 20 elements, right? Where those elements are, or what's in it might be relative to either end, right? Or something, I don't know. Cool. All right, I'm not seeing other questions at the moment. If there's another one floating around there and I'm not seeing it, I'm not trying to ignore it. At me if there's something that I missed, but looks like we're all good here. So Actually, wow, that brings us about to time. That was quick. Oh, well, of course it was quick. We got such a late start. I'm like, what happened? Yeah. Hopefully by early or mid next week. I'm not exactly sure when my new machine will be here, but uh, I believe my streaming quality and troubleshooting stuff will be much improved when that happens. So hopefully in the next week or so here, that won't be an issue ever again. And I do apologize for that and for the late start today. And I'm gonna try to make sure that that never happens anymore. So yeah, it was a pleasure. A lot of fun taking your questions. I do enjoy this. I like the kind of collaborative aspect of it. With everybody seems like there's ideas going back and forth, which is really cool. Do feel free to DM me. Sometimes it takes me a little while to respond, but I will get back to you as soon as possible. If you're watching on YouTube and you're not necessarily joined with Galvanize, you can attend future uh, study halls and ask me questions. It's free to do so. You just sign up and join our basic prep Slack channel, and you can ask me questions. You can DM me outside of study hall hours. I'm open for that. I have a lot of availability for meeting with people and stuff like that if you're interested. So yeah, don't be a stranger. Feel free to reach out. It does help us if you give us a like, comment, if you like, comment, and subscribe on YouTube. We're trying to grow the channel as usual, so I'll make the obligatory plug for that. Of course, if you don't like it, give it the old thumbs down, I suppose. Admit to the world that you didn't enjoy it. That's fine too, I guess. But yeah, till next time, it's been a pleasure. I'll see y'all on Friday. Bye bye.